In this videotape, we will continue our work on factoring. Let's try some examples. Okay, let's start with 3x squared plus 15x plus 12. Okay, we want to factor this. In any factoring problem, the first thing that we do is look for common factors, something that the terms have in common that we could pull out in front. Okay, just don't jump in and start trying to write this as a product of two binomials. See if you can possibly simplify the problem a little. Okay, in this particular problem, we notice that all the terms have 3 as a factor. So we can pull out a 3 in front, leaving us with x squared plus 5x plus 4. This gives you 3x squared plus 15x plus 12. Okay, and now we would like to factor the x squared plus 5x plus 4. Okay, we are looking for two binomials, okay? Two-term polynomial times a two-term polynomial to give us this result. Okay, we know that the first term should be x squared, so we are going to use x and x. Now the question is, what are we going to use over here? We want two numbers here which multiply to plus 4 and add to plus 5. Okay, now it's possible that you can see this right away. After all, how can you multiply to plus 4? Plus 4 and plus 1, or minus 4 and minus 1, or plus 2 and plus 2, and minus 2 and minus 2. Okay, and of those, only one set adds to plus 5. Of course, the answer would be x plus 4 times x plus 1. This gives you, using the FOIL method, x squared. Outer is 1x, inner is 4x, that's the 5x. Last gives you the plus 4. Okay, now let's list all the possibilities. For those of you who can't do it in your head, there's nothing wrong with listing all the possibilities. Okay, when we wanted to factor x squared plus 5x plus 4, we could have, let's see, x plus 4 times x plus 1, x minus 4 times x minus 1, x plus 2 times x plus 2, x minus 2 times x minus 2. Right, all of these satisfy the first and the last terms. Okay, we have x squared for the first and plus 4 for the last. Okay, now we want to add to plus 5. Okay, right away we could eliminate the second and the fourth. Okay, minus 4 and minus 1 multiply to the plus 4, but they add to minus 5. Minus 2 and minus 2 once again multiply to the plus 4, but they add to minus 4. They add to negatives. We want to add to plus 5. You see, the sign over here, you have here two signs involved. The second sign, if that's positive, we know that these two are going to have either be two positives or two negatives. Two positives or two negatives. Then you go over here, and in other words, if this is positive, we go over here and we say, well, if they're going to add to plus 5, it had to be two positives. Right? If it's going to be positive, they're going to add to a positive. And they can be either two positive or two negatives. Obviously, they have to be two positives. Okay? Similarly, if this was a negative number here, we want to multiply to a positive but add to a negative, then obviously we need the two negatives. So we could eliminate these two possibilities and say just consider these two. And checking them, of course, the first one is the correct one. Let's try another problem very similar to this. I just want, instead of having 3x squared plus 15x plus 12, I want to consider 3x squared minus 15x plus 12. Once again, your first step is to say, well, I can pull a 3 out. There's 3 in common in these three terms, and you should pull it out in front, giving you x squared minus 5x plus 4. And now we are looking for two numbers which multiply to plus 4 but add to minus 5. Whereas this is positive, it tells me that the numbers have the same sign, either two positives or two negatives. But if they're going to add to a negative, they have to be negative. Once again, these are still the same. We have the same 4 possibilities to consider. Okay? They give you the last for the 4 and the first of the x squared. Okay, but in this particular case, you can cross out the first and the third from further consideration. It can't be the positives since they have to add to a negative. They must be two negatives which will multiply to a positive but add to a negative. And when you check them out, you see that this last one gives you x squared minus 4x plus 4, and this one x squared minus 5x plus 4, and that's the one we want. X minus 4, x minus 1. Gives us the x squared minus 5x plus 4, which times 3 gives you the original question. Okay, let's try some more problems. Okay, the first thing we notice is that there are no factors in common. There's nothing that we can pull out to simplify the problem any. We look at the last thing here and we see minus 12. The two numbers that we're looking for are going to multiply to minus 12, which means they're going to have opposite signs, a positive and a negative. And they're going to add algebraically to the minus 4. And since they have opposite signs and they're adding to the minus 4, it has the effect of a subtraction. Now, we can list all of the possibilities and pick the one that's correct. Remember, you should be able to go through the possibilities very quickly using the FOIL method. Okay, in this particular case, we get about, let's see, 6 possibilities. You could have x plus 12 times x minus 1, or x minus 12 times x plus 1, x plus 4 times x minus 3, x minus 4 times x plus 3, also x plus 6 times x minus 2, and x minus 6 times x plus 2. Now, how did I get these possibilities? I am looking to have the first terms multiplied to the x squared. In each case, they do. The last terms multiplied to the minus 12. Now, how can I get minus 12 in the integers? Plus 12 and minus 1, or minus 12 and plus 1. Plus 4 and minus 3, or minus 4 and plus 3. Plus 6 and minus 2, minus 6 and plus 2. Okay, so all of them give you the x squared and the minus 12, and it's up to you to look for the ones that are going to give you the minus 4x in the middle. Okay, now, outer minus x, inner 12x, okay, giving you a result of 11x. Here, 1x minus 12x, that's minus 11x. Okay, once this gives you, by the way, the plus 11x, you can realize that this is going to give you the minus 11x and sort of, do them together. Here, minus 3x and plus 4x for the 1x. Here, plus 3x and minus 4x for the minus 1x. So these are out. Okay, minus 2x and plus 6x gives you plus 4x. We're close. We want minus 4x. And the last one is the one that works. Gives you the plus 2x, the minus 6x for the minus 4x in the middle. So this factors into x minus 6 times x plus 2. As I said, we wanted two numbers which multiplied to minus 12 and added to minus 4. Okay, now after a while you'll get better at this and you'll be able to sort of jump to this. In other words, you'll look and you'll say, well, how can I make 12? 12 and 1, 4 and 3, 6 and 2. Okay, but basically we're talking about a subtraction here because the numbers have different signs. Okay, and you can go right away, you say, well, of 12 and 1, 4 and 3, and 6 and 2, the only one that's going to give me the difference that I need of 4 is the 6 and the 2. Educated gets you have a way of starting. Okay, and then you just have to figure out where the minus goes and where the plus goes. Okay, but that's the way your mind should be working. Let's look at this problem. X squared minus 7xy plus 10y squared. Okay, now if this had been x squared minus 7x plus 10, you could probably handle it with not too much difficulty. We want two numbers which multiply to plus 10 and add to minus 7. Now, to multiply to plus 10, either two positives or two negatives. But to add to minus 7 means it had to be two negatives. And the answer turns out to be x minus 5 times x minus 2. Minus 5 and minus 2, they multiply to the plus 10 and add to the minus 7 that you need. X squared minus 2x minus 5x for the minus 7x plus 10. Okay, now the only thing that the y is going to do in this particular case, okay, it'll come into play like this. This will factor x minus 5y times x minus 2y. Let's try the FOIL method on this. We have x times x, x squared, outer minus 2y times x, or minus 2xy, inner minus 5xy, giving you the minus 7xy, and for the last, plus 10y squared. Okay, so don't get too upset if you notice, say, another variable coming into play in this form. Okay, think of how you would factor it without the y, and then you can just throw in the extra variable as we need it over there. Okay, once again, I want to remind you that not every example factors over the integers. If I gave you, say, x squared plus 3x plus 4, okay, you could list all of the possibilities. X plus 4, x plus 1, x plus 2, x plus 2. You could also have the minus 4 and the minus 1, minus 2, and minus 2, but of course we'd rule them out because we know we want to add to a plus 3, which means we have to have the positives. And we see here they multiply to the 4, but here you get a 5x in the middle, here you get a 4x. Neither one of the possibilities gives you the 3x. This can't be factored any further over the integers. Not factorable over the integers. In other words, if you're trying to put integers into the parentheses, you can't do it. Okay, so far, we have always been working with something like 1x squared plus something times x plus a constant. Okay, for the first time, we're going to consider what happens if there is a coefficient of x squared other than 1. Okay, now, if it's just x squared, you know the first terms are x and x here. If it's something other than x squared, you have to consider the ways to make that number as well as the ways to make, say, the plus 10 here. And it gets a little confusing. Also, in this particular instance, when there's just x and x, it doesn't matter if you write it x minus 2 times x minus 5 or x minus 5 times x minus 2. Okay? But if you're going to change, if you have, say, x and something else over here, then you also have to consider doubling the possibilities because the second term has to appear with each of the other ones. Let me give you an example. I'll show you what I mean. Let's work out 2x squared plus 11x plus 5. Okay, now, this is not the worst problem that I could give you because 2 and 5 are at least prime numbers. So we have a limited number of choices here. Okay, let's look at the ways we could do this. Once again, we're going to list the possibilities. It becomes a little harder to do this thing in your head without listing when you have a coefficient for x squared other than 1. Okay, you could have 2x plus 1, x plus 5, 2x plus 5, x plus 1. Okay, you could also, let me just put them down. 2x minus 1, x minus 5, 2x minus 5, x minus 1. Okay, in other words, we needed the first terms to multiply to 2x squared, and the last terms to multiply to plus 5. Now, how can you make plus 5? Either the plus 1, 1 and 5, or minus 1 and minus 5. But now order is important. Okay? If the lead coefficients were just x here instead of 2x, then, of course, these first would be the same. X plus 1 times x plus 5 is the same as x plus 5 times x plus 1. But when you have the 2 in here, we've got to consider the way this is going to affect the answer. Okay, let me write down the answers to these 4 problems. Okay, so you get used to seeing the way these numbers can act on each other. Now, you might also know that the last 2 couldn't possibly be the answer, since the outer and the inner would come out to be a negative and a negative, which would add together to give you a negative here instead of a positive. Okay, this first one, the first term, of course, is the 2x squared. The outer is 5 times 2x, 10x. The inner is 1x. That's the 11x that we want. The last is 5. Okay, but this one would give you 2x squared. The outer is 2x. The inner is 5x. That's 7x. also plus 5. And although we eliminated these from consideration because it gives you a negative for the second term, let me just list them so you'd see them. 2x squared minus 5 times 2 minus 10x minus 1x, that's minus 11x, also plus 5, and the last one, 2x squared minus 2x minus 5x minus 7x plus 5. Okay, so when your second sign is positive, you know that either you'll have two positives or two negatives. And if this is positive, that means they're going to add to a positive, therefore they'd have to be positive to start. If this were negative, like over here, they'd have to add to a negative, so these both would have to be negatives. Okay, so you see that if it was just x squared here, it wouldn't matter the order. X plus 1 times x plus 5, x plus 5 times x plus 1, these would be the same. But we double the possibilities when you throw in the 2 in front. Okay, and this is still a relatively simple problem because 2 and 5 are prime. Let's see what happens when we have a really complicated problem. Okay, now we're going to work out a problem. This is about as bad as they get, actually. Okay, and it can still be worked out, without being clever or anything, just by listing every single possibility. After a while, you'll get better at it, but you can do it by listing every possibility. Okay, the problem we're going to work out is this one. We'd like to factor 10x squared minus x minus 1x minus 21. Okay. Now, 10 is not prime, neither is 21, and we have quite a few possibilities to consider over here. Okay, first thing we notice is that there's nothing in common that we could pull out from these three terms. Okay, so this is about as good as it's going to get. Let's list now all the possibilities, and there are a lot of them. We have to consider all the ways we can make the 10x squared and all the ways we can make the minus 21. The numbers in the second terms in each of the parentheses, of course, will have opposite signs because they're going to multiply to minus 21. Okay, so we could start with 10x and x. And you can make minus 21 with a plus 7 and a minus 3, and also with a minus 7 and a plus 3. Okay, we can also make it with a plus 21 and a minus 1 and a minus 21 and a plus 1. Okay, so for minus 21, either 7 and minus 3, minus 7 and plus 3, 21 and minus 1, minus 21 and 1. Okay, but each of these can be reversed as well. Okay, so we can start, for example, the x could have been here and the 10 could have been there, giving us we could have had the x plus 7 and the 10x minus 3. Okay, the x minus 7 and the 10x plus 3. The plus 21 here and the minus 1 here, and the minus 21 here and the plus 1 here. Okay, that's all the ways we can make minus 21 mixed with the 10 and 1 way of making 10. Okay, now instead of making 10 by 10 and 1, of course, we can make 10 using 5 and 2. Okay, and we have another 8 possibilities this way. We have 5x and 2x. And still, 21 could be made with the plus 7 and the minus 3, the minus 7 and the plus 3, the plus 21 and the minus 1, minus 21 and the plus 1. Okay, and we also have to consider what would happen if the 5x were where the 2x were and the 2x were where the 5x were. Okay, so let's reverse each of these. Now the 2x will be with the plus 7, the 5x will be with the minus 3, minus 7, plus 3, plus 21, minus 1, minus 21, and plus 1. Okay. It's a lot of work, okay, but you can list every single possibility. Okay, each of these, by the way, gives you, of course, the 10x squared and the minus 21. That was the whole idea. So when you're checking, you don't have to worry about, say, first, outer, inner, and last, because you know the first and the last are all right, or you wouldn't have put them down as a possibility. It's really just a matter of checking the outer and the inner. What we're looking for is a net result of minus 1x. Okay. Now, on this problem, okay, if I had to, say, guess, I would sort of think, stay away from the extremes. Okay, in other words, the net result will be a minus 1 from the subtraction. I wouldn't think that you'd make 21 with a 21 and a 1, or that you'd make 10 with a 10 and a 1. In other words, I wouldn't think that they'd be at the extreme since they subtract to a rather small number. I would think that they would probably be, say, the 5 and the 2, the 7 and the 3. So if you feel like trying those first, okay, you can. But it's not a big deal to try them all. You see, over here we have minus 30 and plus 7. Plus 30 and minus 7. Of course, if you do them in pairs, right away, if this is out, then this one is out also, if it's not close at all. Minus 10 plus 21 plus 10 and minus 21. Okay, minus 3 and 70 plus 3 minus 70. Minus 1 and 210 plus 1 and minus 210. You can see what's happening with the extremes. I'm looking for outer and inner to give me the minus 1. I don't think 21 and 1 or 10 and 1 is the way to do it. Okay, now these are the better possibilities here. Okay, minus 15 and plus 14. This is the correct one. Okay, usually it's the end, but it's not so bad here. Minus 15 and plus 14 gives us the minus 1x we were looking for. This would give you, say, the plus x. And you can try the other ones if you want. That's the only one that works. So the answer to this problem, this is 5x plus 7 times 2x minus 3. That's 10x squared minus 15x plus 14x. That's minus 1x minus 21. Okay, it's a lot of work. It's not a difficult idea. You can list all the possibilities. It's something that you can do if you have the patience. Okay, let's try another example. Okay, 5x cubed plus 15x squared minus 20x. Okay, remember the first thing you should always do in a factoring problem is look to see if there's something that these terms have in common that you could pull out in front. I mean, don't say x cubed, I don't know how to factor something with x cubed. Look and see that they all have an x in common, and they all have a 5 in common. And we can pull out a 5x in front, leaving us with x squared plus 3x minus 4. Gives you 5x cubed plus 15x squared minus 20x. Okay, now we want to further factor the x squared plus 3x minus 4. Two numbers which multiply to minus 4 and add to plus 3. This is the easy kind again because we have the 1x squared here. We don't have to consider the ways to make the x squared. It's going to be x and x. Okay, multiplying to minus 4 and adding to plus 3, we're going to have plus 4 and minus 1. You can list all the possibilities. This gives you the minus 1x and the plus 4x, the plus 3x, the minus 4. Okay, nothing, you can list them if you want to. The last thing I want to mention today is a special kind of form that sometimes occurs in polynomials, which can be factored very easily. Okay, before we do that, let's multiply x plus 3 times x minus 3 using the FOIL method. Doing that, we get x squared. The outer is minus 3x, the inner plus 3x, the last minus 9. And notice how the outer and the inner cancel each other out. Minus 3x and plus 3x, that gives you 0. Final answer of x squared minus 9. This is x squared minus 9, or x squared minus 3 squared. It's the difference in two squares. Right? If it helps, you can think of this as x squared minus 3 squared. And notice the relationship between that and what we started with. Let's look at something in this form. X plus a times x minus a. You'd get, using FOIL, x squared. The outer is minus ax, the inner is plus ax, the last minus a squared, and we see that we get x squared minus a squared. Now the real importance, okay, in this idea of the difference in two squares, is not so much for multiplying out. I mean, so if you write it out, outer and inner, you see they cancel each other out, you get that. It's a very handy way of factoring something like this. This is the difference in two squares. If you have to factor the difference in two squares, okay, say something like x squared minus 9. You don't have to go through all the possibilities that we were considering before. How to make the x squared, how to make the minus 9, and so on. Right away you know it's got to be x plus 3 times x minus 3. Or in general, if you have x squared minus a squared, the difference in two squares like that, it must factor into the sum of the numbers times the difference, x plus a times x minus a. For example, if I asked you to factor x squared minus 16, this factors into x. This is really x squared minus 4 squared, right? It factors into x plus 4 times x minus 4. You write it as x squared minus 4 squared. The difference in two squares, okay? And it's in the sum of the numbers, x plus 4 times the difference, x minus 4. Checking it out by FOIL, x squared minus 4x and plus 4x gives you 0x. The middle term drops out, the last minus 16. By the way, this difference in two squares. If I asked you to factor x squared plus 16, you couldn't go any further in the integers. Okay, this is not factorable in the integers. Not factorable over the integers here. X squared plus 16, the sum of two squares, does not factor like this. Only the difference in two squares. Okay, so the last thing I want you to try today is factoring this. 9x squared minus 25. Okay, the first thing to do on this would be to realize this is really the difference in two squares. In other words, take the time to write this as 3x quantity squared minus 5 squared. 3x squared would be 9. 3x quantity squared is 9x squared. It's 3x times 3x. 9x squared minus 25. It's the difference in two squares. This squared minus this squared. So you rewrite it as the sum, 3x plus 5, times the difference, 3x minus 5. And that's the answer. Checking it out by FOIL, you get 9x squared minus 15x plus 15x, they go, minus 25, which is what you want. And that brings us to the end of this videotape.